Okay, my amazing students, we are on page 27. Okay, page 27. We are covering topic 6.9, and this is the last topic to wrap up the unit. So, last video of the unit. Here's the idea. We can take chemical reactions and we can take their change in enthalpy for chemical reactions, and we can combine these in different ways to find a new reaction, and we'll also be able to combine the delta H's in a certain way to figure out what the delta H is for this reaction. So if I have this reaction, like an overall, like this one that I want to figure out what the delta H is for, and then I'm given this table here. So first thing I'm going to notice is that nitrogen dioxide is on the reactant side. So now I'm going to come down here and I'm going to start looking for nitrogen dioxide. So reaction 1 doesn't have any nitrogen dioxide in it. So I'm going to look at reaction 2. And when I look at reaction 2, I notice that nitrogen dioxide is a product on reaction 2. So here's the cool thing. So I'm going to write this one small and then I'm going to do it bigger down here. This is the change in enthalpy for this forward reaction, where 2 nitrogen monoxides plus 1 O2 turns into 2 nitrogen dioxides. What if I take the reverse of that reaction, where 2 NO2 gas turns into 2 nitrogen monoxide gas and 1 O2 gas? It's the reverse reaction of this second reaction here, and if the forward reaction was exothermic, the reverse reaction will be endothermic, and the magnitude will be the same. So the delta H of this reaction that I just wrote down is going to be a positive 114.2 kilojoules, the same as before, but just opposite in sign. Now, this is good. I see that I have nitrogen dioxide on the reactant side now, but notice how this reaction, there's a coefficient of 2 moles of nitrogen dioxide, and we need actually 4 moles of nitrogen dioxide. So if I'm going to double this reaction, now I'm going to write it bigger down below. So I'm going to double that reaction. So we're going to have 4 moles of nitrogen dioxide results in 4 moles of nitrogen monoxide and 2 moles of O2 gas. Okay. The delta H of this new reaction is going to be double that, because I essentially am running this reaction twice. So if I double that reaction, I have 228.4 kilojoules of energy that's going to be absorbed. Great. Now, what other reactants are there? There's an O2, and I have 2 O2s on the product side. Okay, so I'm going to, when I run into this problem where I see that I've got this set up the way that I want, but that oxygen is present in both of these reactions, I'm going to move on to the next one, and so I'll come back to oxygen at the end. I need 2 of these. Oh, it's like a nitrogen peroxide and no, because that would be an O2. If it was N2O2, it would be nitrogen peroxide. So this N2O5, I need 2 of them on the product side. So I'm going to look at my list here, and I'm going to see if any of the species in reaction 1 or reaction 2, where this is located. And this N2O5 is only in reaction 1. But it is on the product side, just like how I want to end with here. The only difference is that in the reaction, I have a coefficient of 1, and I want to end with a coefficient of 2. So I'm going to double this entire reaction, but I'm not going to take the reverse of this. So I'm going to have 4 nitrogen monoxide gas plus, okay, so if I have 3 halves, and I'm going to double that, then I would have 3 O2 gas is going to turn into 2N2O5 gas. And I doubled this reaction, so I need to double my delta H. And so this negative 223.7 is going to be negative 447.4 kilojoules. Okay, now I'm going to tell you, usually at this point, the one that like we haven't looked at yet that we said we're going to save for later because it's showing up on both of the reactions, it usually works out at that point. Let's just check if it did or if we need to go back and fix something. So now that I've got these two reactions, let's add them together to see what the overall reaction is. If something is on both the reactant side and the product side, then it's going to cancel. So we have 4 nitrogen monoxides on the product side, and we have 4 on the reactant side. So those will cancel. And then I have 2 O2 molecules on the product side and 3 on the reactant side. So the 2 will cancel and we'll be left with 1 right there. And now let's put these all together and see what we have. So it'd be 4 nitrogen dioxide gas plus 1 O2 gas. Okay, so that's everything on my reactant side. Will result in, okay, now we're on to the product side, 2N2O5 gas. Great. Now, checking, yep, that's the reaction we want to end with. 4 nitrogen dioxide, 1 O2, and 2 N2O5. So then what is the delta H? So think of this as, let's call this for reaction 1. So this will be delta H of 1, delta H of 2. To get delta H of the overall, where I added those two together, it's just going to equal the delta H1 plus delta H2. So the final answer, my delta H for this reaction, is going to be a positive 228.4 plus the negative 447.4, and so we get negative 219 kilojoules. Oh, okay. I added a 0.0, and here's why. Sometimes it's hard to track sig figs, especially if we're like multiplying or doing the inverse and then we're adding stuff together. And so if you look at the delta H values in the table, we're gonna mimic that. So I'm seeing 1 digit after the decimal, so that's why I went with 1 digit after the decimal here. So this reaction is exothermic. Okay, let's keep going. Okay, so I have example 2, example 3, and then we got example 4. And I think this one has 3 here, so let's do this one together. And then I think I'm going to save number 3 for class. So I see this overall reaction that I want to achieve, and carbon is on the reactant side. So now I'm going to look at all 3 of these reactions, and I'm going to try to find carbon where it's all by itself, carbon solid. And so it's not present in reaction 1. Although carbon is in reaction 2, it's not alone. Only in reaction 3 is it all alone. And so in reaction 3, it's carbon solid plus O2 gas results in carbon dioxide. Now this has a coefficient of 1, and that's a coefficient of 3. So I'm going to take reaction 3, and I'm going to multiply it by 3. So we're going to have 3 carbon solid plus 3 O2 gas results in 3 carbon dioxide gas. And just like before, my delta H for this reaction is right there, but I multiplied that by 3, so I need to multiply this by 3. So my negative 393.5 times by 3 negative 1,180.5 kilojoules. All right, wonderful. Now, let's keep going. So I've addressed this 3 carbons on the reactant side. Now I need to look for H2. H2 is only present in the first reaction. So there's no other reactions 1 through 3 where we have this hydrogen gas all by itself. It's on the reactant side, and that's also true for reaction 1. There is a coefficient of 4 and there's a coefficient of 2. So I'm going to take reaction 1 and I'm going to double it, but I'm not going to reverse it. So I'll have 4H2 gas plus 2O2 gas results in 4H2O liquid. And then same idea with my delta H. I did not take the reverse of the reaction, but I did double the reaction. So I'm going to take this negative 571.7 and I'm going to times it by 2. Negative 1143.4 kilojoules. Great. Now I'm going to look at my products. So C3H8. And I'm going to look at everything that's on these, every item in these reactions, and I'm going to try to find that. And it's only present in reaction 2. So I have a C3H8 plus 5O2 results in 3 carbon dioxide and 4 water molecules liquid. Here it's on the product side, and in this reaction list it's on the reactant side. Coefficient of 1, coefficient of 1. So I'm not going to multiply this reaction by anything, I'm just going to take the inverse of it. So then it's going to be 3 carbon dioxide gas plus 4 H2O liquid results in C3H8 gas plus 5O2 gas. Now for my delta H, I didn't multiply this reaction, I just took the inverse. And this is currently a negative, so I'm going to turn it into a positive. So I've had positive 2220.1 kilojoules. Okay, now I'm going to check. I'm going to add all of these reactions together and see if it does give me the final one that I'm wanting. So if something shows up on both the reactant and the product side, it canceled. So here's the first thing that I'm noticing. 3 carbon dioxides right there on the product side, right here on the reactant side, so that will cancel. Okay. I have 4 water molecules on the product side, and I have 4 on the reactant side, so those will cancel. And then look at this. I have 3O2 plus 2O2. So I currently have 5O2 on my reactant side, and then I have 5O2 on my product side. So essentially I'm saying these 5, that's going to cancel with these 2, and then it's also going to cancel with those 3. That looks like everything that's canceling to me, and so I'm going to put the rest of it together. So we are left with 3 carbon solid plus 4 H2 gas. That's everything on my reactants. Turns into C3H8 gas. Okay, confirming. Yep, that is the reaction we wanted. 3 carbons, 4 H2, 1 C3H8. And just like before, we added all 3 of these reactions together to get this overall reaction. So to get our final delta H for this reaction, we are going to add together the delta H's of those. So I'm going to take this negative 1,180.5 and I'm going to add that to the negative 1,143.4, and I'm going to add that to the positive 2,220.1. And so my final delta H, it's exothermic, and it's negative 103.8 kilojoules. Okay, now just like before, I'm going to look up at my table here, and it's giving me 1 digit after the decimal, and so I'm going to go with 1 digit after the decimal for my delta H. Okay, nice. Okay, this is super nice because we got a shorter video. I want us to do some examples in class. And so I think I'm going to save example 3 and example 4. Yeah, I'm going to save example 3 and example 4 for class time. Quick reminder, the multiple choice for Unit 6, it's going to be in the library, and you can get that done. I'll get it ready for you guys, and so it'll be available Tuesday after school through Friday of next week. And if you have gotten the videos and notes done before each class period, then you've already wrapped up and got the points earned for the free response. If you were unable to do that before each class period, no worries, you still have a chance to earn all of those points for the free response. You're just going to need to do a shorter free response exam, either with me in the classroom, or I'll also take some to the library, and you can do it in there if that's easier. If you have any questions or concerns, feel free to reach out. Thank you guys so much for your hard work, and I will see you on Tuesday.